Hello everyone, welcome to MEDHA CARE. So in this video, we'll see one quick trick from chemical kinetics. Okay, so we'll see quick trick from chemical kinetics. We all know the first order integrated rate equation. That integrated rate equation for a first order is T equal to 1 by K ln A naught divided by AT. So that equation will only work if we have initial concentration of the reactant. Now consider we have a reaction A2 product and the reaction is first order kinetics. Reaction follows first order kinetics. So at T equals to 0, consider the concentration of A is A0 and the concentration of P is 0. At time T, the concentration become AT and it become X. So AT equal to A0 minus X. So we have started from A0. So when the concentration of A0 becomes A0 by 2, then we say that half of the reaction is completed and the time required to change the concentration from A0 to A0 by 2 is called T half, the half-life of the reaction. Consider here we have 100 molecules. Now we will have only 50 molecules because 50% of the molecules is reacted. So here the time is T half. That means 50% of the reaction is completed. So we called it T half. Now from here, see, if we go another T half, what will be the concentration? The concentration will be half of this one, right? Half of this A0 by 2. So it will be A0 by 4 then. If you go another half-life, then it will be A0 by 8 and so on. Now see, here the time required is T half and from A0 to, if we consider up to A0 by 4, we require 2 T half. So here the time, the percentage of the reaction is completed here. See, 50% will become 25%. That means 75% reaction is completed when the concentration becomes A0 by 4. So you can say that the time here is 3 by 4. Okay. So 3 by 4 is actually 75%. So T3 by 4, that will be equal to 2 into T half. So it will be 2 into T half. If we go from A0 to A0 by 8, then the reaction proceeds 3 T halves, right? 3 T halves. Now here the time will be 7 by 8. 75% and remaining 25%, half of the 25% will be consumed here. So the time will be T7 by 8. So T7 by 8 is equal to 3 into T half. So if we go up to 4 T half, then the concentration AT will be A0 divided by 2 to the power 4. Or you can say, for if the reaction proceeds nth T half, then the AT will be A0 by 2 to the power n. So for 50% half T half, if we go 1 T half reaction, the time, if the time goes 1 T half, then it will be A0 by 2. If it goes 2 T half, then it will be A0 by 4. 3 T half, A0 by 8. So if the reaction proceeds n T half, then it will be A0 by 2 to the power n. and then the time will be 2 to the power n minus 1 divided by 2 to the power n, and that is equal to n into t half. Now see, if the reaction proceeds 87.5%, okay, if the reaction 87.5% of the reaction is completed, then T, the time required for completion of 87.5% will be, see here, first it is 50%, then half of 50% is 25%, so up to here the reaction 75% of the reaction is completed. Now from 25% to here it will be completed another 12.5%, so 75 plus 12.5, that will be 87.5%. So 87.5% is actually 3 t half. So you can say the 87.5% is 3 t half, so n equal to 3, so it will be 7 by 8, that is 3 into t half. Okay, so 7 by 8 will be 3 into t half. Now see, if the reaction proceeds 99.9%, you know already that one. If the reaction proceeds 99.9%, that will be 1024 and 1023, T1023 divided by 1024, and that will be approximately 10 into t half. So always remember, the denominator here will be 2 to the power n. So you can think about it like the memory, the bit memory of a memory card. So we have 2 GB, 4 GB, 8 GB, then it will be 16 GB. So here it will be A0 by 16, and then the reaction will go up to 1, 2, 3, 4 t half. So if the initial concentration is A0 and the final concentration is A0 by 16, or they can ask A0 by 32, what is the time required? From A0 to 16, you see the AT will be A0 by 2 to the power n. So 2 to the power n is 16, so n will be 4. So n will be 4, that means n into t half, 4 into t half time will be required here. Here 2 to the power 5, so 5 into t half time will be required. Okay, so using this trick you can solve the question within a second, that how much time is required to complete 75% of a reaction, 87.5% of a reaction, and T7 by 8, T1023 by 1024, T3 by 4, everything we can calculate easily. Okay, so thank you very much for watching this video. Hope you will like this video. Please hit the subscribe button and share the video with your friends. Thank you.